Okay, all right. I'd like to call to order this work session at the Anchorage Assembly and begin by going around the table.
Dick Training. Adam Trombley. Ernie Hall.
Paul, you're there?
Paul Holman on the phone.
Paul Honeman is on the phone. Debbie Osiander.
Jennifer Johnston.
Eugene Ori, ML&P staff.
Posey?
Jim Posey, ML&P. Or Alden, contract to ML&P.
Very good. Mr. Posey, the floor is yours. And may we interrupt with questions? Or
Absolutely.
Okay.
Would prefer to do that so that you get all your answers while the questions are hot. What we have here is the continuation of our process over the last 5 years to continue to rationalize our generation assets in order to make sure that we can continue to deliver 4 nines of reliability. 4 nines of reliability is better than the Alaska pipeline. Probably the highest reliability in the state by records. We'd like to continue to do that. We'd like to continue to be efficient, and we'd like to be a lot cleaner. And all of that drove our RFP to say that if we continue to try to do maintenance on the old equipment, over time it would cost a great deal more to try to keep old 30 and 40-year-old turbines running rather than replace them with new, cleaner, more efficient. And efficient means that we save 25 to 30% of the precious gas that we have. And cleaner means over 90% cleaner on the various controlled emissions that we have with EPA and DEC. So with that, I'll turn it over to Eugene Ori, who's my project leader, manager, and he has a nice shot of the last brand new unit to be put in the state of Alaska. That was our LM2500 Plus at Plant 1, and we paid for that with cash back then because it was the best way to utilize the money we had. Eugene.
Thank you, Mr. Posey, Madam Chair, and Assembly members. My name is Eugene Ori. I'm repowering projects manager for ML&P, heading up the effort to repower our generation fleet. And our presentation will be about 20 minutes. You can feel free to interrupt, or we can ask questions at the end, but feel free to speak up and interrupt to step through this.
All right, well, real quickly then, Harriet Drummond has joined us for the record. Sorry, go ahead.
Okay, background, ML&P's primary mission is to provide cheap, reliable power at the cheapest cost to our ratepayers, and we do so through 2 thermal power plants. Power Plant 1 down at First and Ingra produces about 99 megawatts, and Power Plant 2 at the Muldoon and the Glen Highway that we're all familiar with, about 242 megawatt capability, as well as our ownership interest in 2 hydroelectric projects. We own the majority of the Clutha Power Project, and we're 26% interest in the Bradley Lake project. So that's how we serve our customers, and I want to take us to the next slide, and we'll take a little bit deeper look at our thermal generation, our gas turbines and fleet. And we've broken it down here. I have it organized in color-coded green, yellow, red in terms of age. 0 to 30 years old is green, which is these turbines are designed to last 30 years. Yellow are the turbines that are 30 to 40 years old, and red is above 40 years old, approaching 50 years old. And some key takeaways here are that we have a lot of hours on our existing fleet, and they're very old. And we've, for example, unit number 7 here is the high time turbine in the world for this type of turbine, and it's a fleet leader. We've got our money out of this old equipment. Next slide. The average age for our equipment is 33 years old. Beyond the original design life of the equipment, you can extend the life of things by taking care of it with TLC and additional capital cost. But it is becoming harder to maintain these turbines to keep the reliability that we need, the 4 nines Mr. Posey was talking about. And it's becoming more expensive to maintain them when you can find the parts. You can't, some of these parts have to be custom made because they're 1960s and 1970s parts that have to be remanufactured for maintenance. In addition to that, we're just having we're starting to have to inflect upward the amount of capital we put in this old equipment to keep them running, and not to mention reliable. And then finally, they're old, and they're inefficient. And these turbines were designed in the 50s and 60s, built in the 60s and 70s, before EPA, and they weren't designed with Mother Nature in mind, well before the Clean Air Act. Next slide. So that's about the turbines, but there's also piping and auxiliary equipment around the turbines that make up the balance of plant, that make up the rest of the power plant. That's also old and becoming broken down and becoming harder to maintain and keep the power plant safe. So it's a two-pronged issue. What we got here is, if you might remember in 2009, in the middle of winter, we had a rupture of a major cooling line out of plant 2, and we flooded the facility with 500,000 gallons of water. It was about 5 to 10 degrees below zero. We had a real mess on our hands, and we were real lucky we didn't destroy more equipment with this rupture. But that pipe there that rusted through did its job for 30 years. It was over 30 years old. So anyhow, these are some of the issues we have with staying reliable with our power plants. So let's talk about some of the solutions. One prong of that solution would be the agreement that we went in with Chigash Electric in 2008 to jointly build a power plant. That power plant is under construction now over at CEA's headquarters. We stepped into that to a 30% ownership interest, and that is going to be online by the end of 2012. In addition to that, we embarked on a integrated resource plan study where we looked at all the factors that are involved with generation planning, from our load growth, the age of our equipment, the availability of fuel, the availability of different types of power generation equipment, and its reliability and cost. And we did an economic analysis within this IRP and came up with a preferred scenario. So within this report, we need to understand a little bit of the planning. This first line here off to the left is our ML&P's peak load, 187 megawatts last year. But in order to serve that peak load at all times, you have to have what's known as spinning reserves and operating reserves. A percentage higher of the peak load of equipment that's spinning and ready to go, throttle, if you will, ready to ramp up in case any turbine trips either in our fleet or in the interconnected rail belt, Chugach, or even Golden Valley. We share in this extra spinning capability we have running. In addition to that, we plan for an N-2 contingency where you might have a forced outage on one of your big machines, and then you might have an issue where a second machine trips and you still need to keep the lights on. And that's what this orange line above it is. And so prudent utility practices, we maintain this level of generation capability. We overlay that with our turbine fleet capability, and we have it color coordinated here. The blue is hydroelectric, the green is our turbines that are less than 30 years old, yellow 30 to 40, and again, our equipment that's over 40 years old, some in cases approaching 50 years old. And you can see over here that we're barely meeting our generation with equipment within its design life window. And very shortly, we make an increasing fraction of our peak load with old and increasingly unreliable equipment. We'll note here that this step change up is when SPP comes online next year. But the very next year, we go way back down, and that's because one of our main turbines is aging, and she becomes older and past that 30-year design life. So you can see that we kind of have a waterfall in assets base and age.
Yeah.
I'm sorry, there was a little murmur down here at the turbine being sheet.
But you know, we're very good energy producers. That's correct.
Relative.
Eugene, I have a question for you. Right around 2028, are we expecting some impending doom there? Kind of drops off.
Would that be this?
Yeah. Well, no, the maintenance line, the maintenance contingency.
Well, what this is what's really happening is our old equipment is growing to a really large fraction, and then it just drops off. And what this is we're saying that at 50 years old, we can't, we got to retire these things.
Yeah.
And so they're dropping off, and this big drop off corresponds with
Oh, I got you.
that.
Sure.
That big turbine that's being retired is part of that formula that makes that line. So the takeaway there is we have a problem now that we need to address. The obvious problem is in the future we have a bigger problem, but we can address that out there in 2018, 2020. But this integrated resource plan is a today look, how can we take care of ourselves tomorrow? It's intended to, you do it every 5 to 7 years to look at your portfolio and see what you need to do. So I would draw our attention to over here now. Obviously this is a trouble out in the future. Next slide, please. Okay, so the results of that IRP were that we had several scenarios, I think 9, and we economically chose to go with scenario number 7, and that was as follows. A 30 megawatt simple cycle turbine down at plant 1, very similar to the one we put in 2007, and then a 60 megawatt combined cycle power block at plant 2, a plant 2 expansion. And that is what our recommendation that was recommended and approved by our board in 2009. Next slide, please. A little bit deeper look at the plant 1 turbine expansion. We would put a similar turbine, this model ML&P plus, that is similar to the one we put before. We do it for like-kind spares and familiarity with the unit. We result in significant gas reduction. And a reason to put it down at plant 1 is having it at plant 1 makes it more available within the core business district. The older downtown Port to 9th Avenue and electrical district is built a little differently than the rest of the system, and it's good to have generation close to that.
Ms. Johnson?
And you might have this in the next slide, but how much less, what's your efficiency with the units now, increase efficiency, and how much gas would be required to operate them, and how much more energy would be produced?
Okay, we recently we will be using 25 to almost 30% less gas to produce a kilowatt over the current equipment that we're replacing. And so this plan of a project down at plant 1 and an expansion of plant 2 is roughly 90 megawatts of replacement power that would be roughly 25% more efficient. And that's how we looked at it. Does that answer your question?
We go from about 12 BCF a year down to a little over 9.
Okay.
Under the current plan, I mean, you could bounce that around a little bit.
90 megawatt production, for 90 megawatt production.
No, for the 187
Right.
average during the year. So what he's saying is that by replacing this one at plant 1, then what we're planning to do at plant 2, you add that to what we're getting the results of from SPP, or another 6,000, and you end up with 25 to 30% less gas being used.
Okay. So,
I have a question. On the infrastructure, I think the slide before this, you talked about new infrastructure being necessary, like a new building, but in this one, it looks like you're replacing. So do you need a new building, or do you just pull out a turbine and stick in a turbine in the hole?
It's both. At plant 1, we'll take out the 1962, the first turbine in Alaska. Hopefully we can put it in a museum if somebody wants to pay for it.
Not us.
Not us, not you guys. But you will slam that 2,500 into that same space. But when you get out to plant 2, you can't take anything out of service while you're still depending on it. Because at plant 1, unit 1 and 2, we have planned to run to failure if we have to, emergency. But otherwise, you don't do anything more than test. You don't run it every day. It's like my Ford 150, 1990 vintage. I would not drive it to Fairbanks every day, but I know I can drive it 4 times a week and be okay. So the same thing here, you take the unit.
We leverage the existing building and infrastructure at plant 1 and just put a new turbine in there. But at plant 2, we would build a new building. That picture of the rusty pipe that ruptured, we don't want to be putting new equipment in an old building with old, it's easy to replace. Coincidentally, the picture you have there on the cover of the presentation is an aeroderivative engine that is lightweight. It's basically an aircraft engine that's been pressed into power generation service, and it's real lightweight, and it can be replaced much easier and quicker than the big heavy frames that we traditionally have.
Just as a follow-up on those turbines, is there any market value for those? I mean,
For the old stuff?
third world countries?
There absolutely is. It's funny. I get emails every day. Salesmen trying to. I heard you got an old turbine. I want to put it in Colombia. And we intend to assign the old equipment to a contractor as is, where is, no warranty. But we intend to tell them that there's.
So they have salvage rights.
Exactly.
On that when they bid,
but there is value there. Exotic materials, copper in the old generators, etc.
Thank you.
Plant 2. Next. Again, this 60 megawatt mine cycle block would be a real big hit in the gas savings because it'd be base loaded up at 60 megawatts all year long, and we really see a significant savings in gas right now. We're going to build on our own property. We're not looking to expand on Centennial Park or anything like that, and we're leveraging assets that are already out there. Switch yards, transmission lines. We're kind of doing surgery and not building a totally greenfield site. Keynote here, and Mr. Michaelis would appreciate this as well as others, but we're going to keep plant 2, which has liquid fuel capability as backup. ML&P is the only utility that maintains 2 forms of fuel, and as we might know that with gas shortages or issues of delivery, etc., we're looking to take care of our own customers and/or implement and secure emergency procedures to run on liquid fuel. So we keep the old stuff as a backup emergency standby for those issues.
Mr. Trina?
How long of a backup does that give us? Hours or days?
We keep 5 days.
I know it's expensive. I've seen Juno.
Yeah, we keep about just shy of 1 million gallons of diesel at plant 2, and we would have about 3.5 to 5 days worth of fuel, depending on it. And then it's time to bring a train of trucks to resupply, 1 an hour every hour.
That's all I wanted to know. That solves my question.
10,000 gallons an hour to run the equipment at plant 1. That's a lot of trucks.
I've seen Juno go through this with their little issues.
But by building smaller turbines, not giant ones, we will be able to reduce that extra throttle that we have to maintain that spinning reserve by about over 50%. This results in additional savings, and that's good.
Have you looked at the footprint on the property to see where the building will be? Is it closer to the park boundary? And it is not good.
We'll show you a picture
We'll show
at
you.
the end of this.
Yeah.
Okay, we need a picture.
Yes. Okay, next slide. This is my favorite, and this is why I kind of am passionate behind this. I came back to Alaska from working for a big company because it was low-hanging fruit. We had old stuff, and I wanted to put in new and more efficient things. It's hard to believe that we're going to reduce the NOx, the smog-forming pollutant, by 97%, but that's because we're putting back-end control and we're leapfrogging generations of technology, the newest and latest equipment out there. It's going to produce 80% less CO, and this stat's pretty impressive too. By replacing 100 megawatts of generation with this new and efficient and clean power, it's like taking 125,000 cars off the road. It's great. And it's not just, this is another stat that shows the magnitude that just these projects will decrease overall Alaska's pollution footprint by over 7%. So,
Mr. Trombley?
Yeah, I have two, I do need to head out. I got two questions. One of them was, I know that there's going to be an initial capital investment, which needs to be paid for through the ratepayers. I know, and I understand a lot of this is based on the price of gas, but overall, you're going to find a decrease in usage. Would there be a decrease in ratepayers?
I could jump right ahead to that.
But you don't have to. If it's in the packet, I can
Yeah.
read it. I can always contact you later. And then I guess the other question I had was, with the new turbines, is there additional earthquake safety, stuff like that, so we don't run into having to use diesel?
You say you got to leave?
I do, yes. I can always contact you later.
Contact us and we'll spend some more time with you. Okay.
I apologize. Sorry, no.
To answer your question, Mr. Trombley, power plants are kind of funny. There's so much steel and concrete in them that they survive earthquakes very well. The two turbines going to rip out at Plant 1 were operating during the 1964 earthquake.
Oh.
And it's my understanding they only shut down because the fuel lines in the plant broke. So the infrastructure is class 1, built to class 1 standards, hospitals and critical facilities. And yes, very much thought is given to seismic issues and whatever. And your second question was rate impact. Let me see if I got this right. Right now, we're about 20 to 30% cheaper in terms of average bill compared to our other sister utilities in the rail belt. And throughout this process and the required rate increases we're going to go for, we're still going to be able to maintain debt service equity coverage ratios as required, pay our dividends, and still maintain that 20 to 30% cheaper than the next guy.
But more importantly, I think for you is that through our program of helping both commercial and residential, along with the state of Alaska, everybody could, if they really worked at it hard and made some investment or take advantage of the investment the state is making, reduce their bills by 20 to 27%, which is about what we're going to have as rate increases in order to cover this big capital program. So technically, if everyone did what they can do efficiency-wise, electrically and gas, we could levelize the actual amount of money we take and still cover what we have to do. So,
one more neat, feel-good environmental slide, then I'll wrap it up towards a conclusion here. This is what's interesting. By having the unique capability of having the city's water main flow right in front of Plant 2, it becomes economically easily done to take warm water from the plant that we would normally reject to atmosphere in the form of the water vapor cloud that we see on the east side at Plant 2, run it through a heat exchanger, cool the water back to the plant, warm up the icy cold glacial Klutna water to the end users of Anchorage. And this is a great synergy with AWW. We're gonna increase their the water about 12 degrees from 35 to the mid 40s. They're going to see less frost jacking of their hydrants and less maintenance on their system. And by just having 10, 15 degree warmer water, over 100,000 water heaters across town, it really starts to add up how much gas is not burned in all these water heaters and the associated pollution. It adds up. So we were aiming to be over 70% thermally efficient. That's some techno term, but what it really makes our project potentially one of the most efficient power plants in the United States. That's kind of exciting.
The assembly was presented with a plan to use that warm water for a greenhouse from a group.
Yes.
Whatever
small
happened?
screen. They're still pursuing it, but they still don't have all the money yet. We're still quite capable of helping them out. That's
And
a
doing both.
small stream. Oh, yes.
Yes.
We could even, if you decided to move the greenhouses over here, still enough heat rejection to work.
Okay, next slide, please. Okay, so pulling it to summary, we're gonna have an increase or a decrease in gas, 11% over the already claimed decreases in gas by our share of SPP that we're gonna be getting, totaling about 25% savings in gas, like the question that was asked earlier. Maintenance will fall very much so. NPV savings to ratepayer is about $194 million. And we're gonna, like Mr. Trombley asked, we're gonna be able to not see offset rate increases with the increase in efficiency, and it'll be a level overall rate. We'll be able to meet all of our load with new and very efficient equipment. It'll be distributed. It'll be at plant 2. It'll be at plant 1. A little bit will be coming from Chugach, the SPP plant. That's a good thing. It relieves congestion on our transmission lines, delays capital investment in upgrading our transmission lines. It's good all around. And then, because they're jet engines, they're aircraft engines, they start, stop fast, they react faster, and they're small, there'll be savings in dispatching. We're going to direct procure another 2,500 plus engine and assign it to a contractor to build at plant 1. At plant 2, we have an RFP out on the street for a gas turbine, the larger gas turbine that's due next week, and we'll be evaluating them and recommending an award soon. We're going to assign this gas turbine to another contractor that we competitively bid. This will all be next year. And we're also going to be preparing the site with an ITV to level the hill and prepare it to assign it to a contractor in 2012. Total cost for both projects is going to be $188 million approximately for 90 megawatts of repowering. The metric there is about just shy of $2,100 a kilowatt for installed for a new power plant. As a point of reference, the SPP power plant is going in for about $2,200 to $2,300 a kilowatt, so we're actually going to come in under that. Like I said, we're in the middle of RFP, and we intend to bring to the Assembly recommendation for award in April, and then go out for qualifications, RFP, and eventually a contract award for the 2 construction contracts by the end of next year.
Mr. Birch has a question.
I just had a question on, you're seeing a lot of, design, build, operate, kind of full package where you take in the life cycle costs over the life of the plant facility. Is that incorporated in some way, or did you even look at the kind of the operational component as being or did you zero in on the turbines you wanted and just told everybody to bid to those turbines?
The answer is no. We're set up to operate our own equipment. Yeah, and so no, we're to build us a facility that we will operate is what we went after.
And the reason for that is that basically having the requirement to have the old equipment and also to have the fuel liability that we have for having it on site, diesel oil, a contractor would charge you exponentially to carry risk. And part of the reason why we like to buy, and this is what we did with SPP, with Chugach, you buy the equipment to remove the risk costs from the contractor, because when you do that, you select what works best in Alaska, because you sometimes have people come in and say, this will work for you, but they can't guarantee it for 30 years, and they don't. They don't have the bonding capacity to do that. Okay?
You can see the project schedule there, next slide.
I'm sorry, we've
done.
run out of time. How many slides do
We're
you
done.
have?
Oh, you gotta show the picture.
Well, okay, we talked about how we're going to maintain it cheaper than, and this is plant 2, and this is our rendition of what the facility will look like.
Which is the new, I'm sorry.
The blue stripe.
So it's away from the park.
That's the park is over here.
Very cool.
Just
Mr.
one final.
Flynn, I'm sorry, Mr. Flynn.
On your first slide, you said the hydroelectric annual average output is approximately 1/3 of rated capacity.
Yes, sir. That's because we're managing lake levels, and there's not enough water rights and/or water to run them at full blast all year round.
Okay, so what you're saying is the turbines could go faster if we had more water, but we don't.
Or longer.
Longer, not faster.
The other two.
Longer, okay. All right, thank you. That's all I needed.
You can have like a minute summary, but I've got to close it.
No, that's fine.
Anything else?
I've entertained questions.
Paul, real quick?
Do it offline if need to, but has there been projections on any of the alternative energy like Watana Dam if it comes online wind and also?
We'll spend some more time with
Thank
you
you.
on that.
I don't know if
That
that's
is a big deal now. We are willing to commit up to a certain percentage of that because what it does is back more gas out, and that's okay.
One final note is we did take this plan to the Northeast Community Council last month, and they were very pleased with us
Going that way.
going that way, not this way.
Yes.
I'll echo that. I'll echo that.
Thank you
I
for your
would take
time.
a river if that helps.
No, that community council has been very, very concerned about your upcoming plan, so,
And we took that heart attack away.
very good.
Great, great
Thank you
brief,
very
thank you.
Thank you.
Thank you, sorry about the time.
Okay.